So in this lesson we're going to learn about the sine rule. And the sine rule is this equation down here. And undoubtedly in any exam that you do, you will have it there, okay? Now, yeah, and it's in your formula sheet. So let's look at it. We've got A, B, C in this triangle, okay? And opposite to A, this side length here is going to be B, little a, sorry, I should change back. All right, now opposite B is little b, and that means the whole side length. And then opposite C, and you can probably see, is little c. So it's saying it's really important to understand the formula is that this side length is opposite that angle, okay? And that's all we really need to know, okay? So use opposite sides of angles to determine how to use the sine rule. Okay, let's look at an example. So we need to solve for x, okay? So we need to get our equation going. Now, one thing I didn't notice is that normally we only use 2, okay? The point is that you can use that all three will equal each other, but normally we use 2, and that's what we'll be doing here. Okay, so I'm going to be going x over what's opposite it, sine 30 is equal to, the side length is 11 and the angle is 20, is going to be 11 sine 120 degrees. Now this is really good. I can put sine 30 in my calculator, or I can use all stations to central, and I get a half. Okay, so x equals a half. Let's use all stations to central. All right, 30 degrees is there, so it's going to be positive. And we look at our triangles that are in your formula sheet, and we can clearly see that it's a half. Now 120 will be up here, and that means the related angle is 60, that makes it horizontal. So 120, the exact value will be root 3 on 2 because of this. Opposite 60 is root 3, hypotenuse is 2, so, and it's sine 120. Okay, let's just solve for x. So that means that x over a half will be 2 times 11 over root 3. So I've just flipped this over and multiplied it back up. So x equals 22 root 3 times a half. So I've just moved that over to the other side. So that will cancel out and we'll get 11 at the top there. So therefore x equals 11 root 3. Okay? So that's an example of how we can use the sine rule to calculate a side length. Now, how do we use a sine rule to calculate an angle? Well, that's what our next example is. Now, I want to explain something. In your formula sheet, the sine rule is written just like this in the learning goal, okay? So it's like, I'm just going to write the part that we need to use. Sine A is equal to B over sine B. But it works just the same if we flip it over and we do the reciprocal. If we do sine A over A is equal to sine B over B. Okay. Now the reason why I want to use this here is that I need to find an angle. Okay. So it would be preferable if I put it at the top. But it doesn't matter. As long as you rearrange and use the equation rules correctly, you'll get to the same amount. So I'm going to use it this way. So what's our angle? Theta. Sine theta over opposite that is 12 is equal to sine 30 over what's opposite that, 6 root 2. Okay, let's go for it. Sine theta is equal to sine 30. I have an answer for sine 30. Let's do it later. And we've got 6 root 2, and then because I moved the 12 over times 12, now that's actually really good because I can cancel that down, and I'm left with a 2, all right? Now, sine 30 we did over here, okay, and it was a half, and probably something that we need to get used to. And a half times 2 is just 1. Sine 30, so I'm going to write it out. Half times this 2 over root 2. So that means we're left with sine theta equals 1 on root 2. Now, if we go back to this triangle, that is one of our special angles. So we don't even need a calculator. You could use your calculator and get to the same result. Up to you what you want to do. But 1 on root 2 will be this over this, won't it? So that means 1 on root 2. Oh no, that's not the... Well, you've got to use the other triangle, sorry. Here I am getting ahead of myself. So 45, 45. So that's 2, root 2. All right, so it's going to be opposite over hypotenuse, so it's going to be theta equals 45 degrees. Now, we have a problem, okay? This is what's called the ambiguous case, all right? Okay, the problem is that if I put 45 there, it works, okay? But if I use all stations to central, notice that sine is positive here, so that's our 45 degrees, but it's also positive here, okay? So if I got 45 there, then this will be 135. Now, theta could be 135 degrees as well, okay? Why? What's the angle sum of a triangle? 180 degrees. Now, if I put 135 plus 30, that's 165 degrees. So this could potentially be 15 degrees, okay? It could also be, what is that, 75, 105 degrees. It doesn't look like it's going to be 105 degrees. It looks like it's going to be more 15 degrees, but we haven't been told that. So this one could be 135 degrees because of all stations to central. Okay, they're both positive and they both will simplify down to this. So this is what's called the ambiguous case. Now, what do we do with the ambiguous case? Sometimes we just have to leave it. Often questions will have more information and where you are led to like one answer or the other. Okay? Anyway, this is just the notes. Peace out.